Welcome to another MyNote series video. In this video, we are going to look at a question from a test, and specifically, we are focusing on ungrouped data. So there are a few subtopics that we'll focus on. We're going to start with the mean, the standard deviation, a 5-number summary, which then leads you to draw a box and whisker plot. And finally, we are going to look at outliers. So this is a question from one of the question papers, the previous question papers that were written by grade 11. It says the data below shows the number of people visiting a local clinic per day to be vaccinated against COVID-19. Now, the first thing that you will notice when you look at this data set is that the numbers are scrambled. And I'm sure that when you learned in class about ungrouped data, you were told that you need to rearrange those numbers into ascending order. So just keep that in mind. Now, these are your questions, and they are asking you to determine a number of things like the mean, the standard deviation, and so on. So let's focus on each question specifically. Now, the data below shows the number of people. So this is what we were given. So the first thing, as we already spoke, we need to rearrange the data in ascending order. So now you have rearranged starting from the smallest, which is 5, and going to the maximum, which is 37. This will then allow you to answer this question. Now, when it comes to determining the mean, you need to use your calculator. I will link videos in this video that will show you how to use your calculator to get the mean for the given data or any ungrouped data. So using your calculator, you can find that your mean will be 21.47. Again, with the standard deviation, we also use a calculator to make our life much easier. So you will use your calculator and you will find your standard deviation. Again, the video will be linked to show you how you can find the standard deviation using your calculator. Now, furthermore, we are then asked with regards to the standard deviation to determine the number of people vaccinated against COVID-19 that lies within one standard deviation of the mean. The first step in such a question is to think about what guides you, and what guides you is the interval. So this interval is based on both the mean and the standard deviation. So the lower limits of the interval, or the lower fence, whichever word you prefer, is determined by subtracting the standard deviation from your mean, and then the upper limits is found by adding your standard deviation to your mean. Now, fortunately, we've calculated these values in the two questions above. So you just plug in those values and then you get your interval. So what are we saying here? We are saying that all the values in the data set given that fall within this interval, so from 13.66 to 29.28, anything that is within this interval is going to be counted as part of the solution, because the keyword there is within. Now, this is our data set that were given in ascending order, and it is very important that you have your data set in ascending order in order to answer this question correctly. Now, I've highlighted with the light blue shade all the numbers that fall within this interval that we've just found. So 13 is smaller than 13.66, and that is why it is not part of the interval. It is outside 1 standard deviation. As well, on the upper side, 33 is bigger than 29.28, and therefore it falls outside our interval. Now, when you count these numbers, you will see that there are 13 days that had people who came to vaccinate lying within 1 standard deviation. The next question says, determine the interquartile range for the given data. Now, I always say this when I talk to my students. This question has questions within it. To determine the interquartile range, there's a formula. Interquartile range is equal to Q3 minus Q1. In other words, you need to first determine what Q3 is and what Q1 is. Then you can answer this question. So this is our data set. Now, what I've done here, I've actually just highlighted the minimum value, because when you think about finding Q3 and Q1, you can't help but think of the 5-number summary as well. So this is our minimum, and this blob is supposed to be there at 37, so that would be our maximum. Now this is our Q2. So this is the value which is in the middle. In total, we have 19 values here. So this is our value in the middle. Now this means if 21 is our Q2, we now have a lower part of the data, and within this lower half we can then find our Q1, which should be in the middle. So this is our Q1, which is 18. Once more, since we have a lower half, we must also have an upper half, and this is our upper half, and again we can find our Q3, which will be in the middle. Now we are able to find the middle in these questions because we are dealing with odd numbers, so it is easier to find the middle. But if you had even numbers, you would have to add the 2 middle numbers and then divide by 2 to find your Q2, your Q1, or your Q3. So the interquartile range is Q3 minus Q1. We just plug in the values, 26 minus 18, which will give us 8. The question here says draw a box and whisker diagram to represent the data. Now, from the previous question, we had already found the 5-number summary when we wanted to find Q3 and Q1. So this is our box and whisker plot. Now, when it comes to this question, the key thing is choosing a correct scale. Whatever scale that you choose, you must be consistent with it. And you also look at the numbers that you are dealing with. So for instance, if you chose a scale that was inappropriate, then your box and whisker diagram will also be very difficult to draw or will be distorted. So make sure that you choose an appropriate scale. Now, when you've drawn your box and whisker diagram, make sure that all the key numbers, your minimums, Q1s and Q3, they are aligned correctly on the number line. So if you look, our minimum is 5, and that is reflected on the number line. Our Q1 as well as 18, you can see that on the box and whisker plots, as well with Q2, Q3, and finally our maximum. And then finally, the last question says we must identify any outliers in this data set, and we must also substantiate, or in other words, support or show how we arrived to that answer. So in order to identify outliers, we have two very simple formulae that help us to identify the lower fence or the lower limits, as well as the upper fence or the upper limits. Now, you would have learnt about these formulas. You found Q1, you found the interquartile range, as well as Q3. So it's all just substitution, and then you get your lower fence and your upper fence. So similar to what we did in 1.3, so this is your interval. So any number that is lower than 6 will be considered an outlier. Any number bigger than 38 in the data set will be considered an outlier. Now this is our data set, and then I've highlighted our limits and everything that is within, in order to see if we have anything that lies outside the limits. And what you will notice that our maximum is 37, and if we had an outlier on the upper side, it would be greater than 38. But since our maximum is 37, that means there is no outlier in the upper limits. However, on the lower side, it is said that an outlier should be less than 6. So you can see our minimum is 5, and that means that 5 is an outlier. Thanks for watching. Don't forget to like and subscribe.